Right, a particular electric vehicle was tested to assess the distance it can travel when fully charged. A sample of 20 results. 20. Right, so n equals 20. So n is less than 30. That's the magic number when it comes to stats and the formulas, right? Because if it's less than 30, we use one formula, and if it's greater than 30, we use a different formula. So these are the distances in kilometers that 20 these items went, or cars, or whatever they are, right? Assuming the distance when traveled when fully charged are normally distributed, find the 95% confidence interval for the mean total travel distance mu. So we'll go to the back of the exam sheet and we get the formula that we want. And this is it here, confidence intervals, because it said confidence intervals in the question there, didn't it? It said confidence intervals, right? So let's see, right? Confidence intervals for the mean. So the mean, the symbol for the mean is mu. Mu, the Greek symbol, is our mean. Now this is one formula here possibly, but this has got the z bit in it, right? And z only applies if you're 30, or if the sample size is 30 or greater, you see it says here. So we're scrapping that, we're not going to go with that. And the other confidence interval for the mean is down here. And you can see that that is n less than 30, and we have n equal to 20. So we're going to use this particular formula here. Okay, so I'm going to cut that guy out. And I'm going to cut him. Control X. And I'm going to paste them somewhere else. Stick them up there in the corner. Right. And I'm going to get rid of the rest of this stuff if I can. So now we have our formula. We need x bar, which is the mean of our 20 measurements there. And we need this S hat, which is the standard deviation from our 20 measurements. And the way we're going to do that is we're going to use a calculator. So you press mode on this calculator, you press mode and 2 for stat, and then you get this formula here. And I'm going to go 1 for single variable, press 1 for single variable, and then I get this kind of column effort here. And I'm going to enter in the 20 values, 372, 380. I'll just pause now while I do that. So I've entered in my 20 values into the calculator, and then I can press the on key, and while the calculator is in stat mode, it'll still have those 20 values stored. So now I'm going to get the mean x bar here. So I'm going to press shift stat and 4 for var, and then 2 for x bar. So this menu comes up here, so I'm going to press 2 for x bar, and it gives me 383.45. And next up, I'm going to do a similar procedure to get S hat. So I'm going to shift stat 4 for var, and then you have SX on the calculator 4. You get this 4 and the formula or the menu goes SX like that, and that's the one we're selecting 4. Press 4, press equals, and that gives me my predicted or my sample standard deviation 5.98, and that's rounded to 2 decimal places. So now we have the x bar bit of the formula, and we have the s hat, and root n is just going to be the square root of 20. So we have quite a few bits, and now we need to go after our t value. You see this n minus 1, well our n is 20, so n minus 1 will equal 19. That's known as our degrees of freedom. So we'll be looking up the table for 19 degrees of freedom. And then this is going to be on page 41. Page 41 of your logbooks. And then we need to figure out what particular column we're going to be looking for there, right? So there's maybe 10 columns across, And we figured that out by looking at the 95% confidence interval. Now this is going to be a two-tailed test. So we're trying to figure out values for mu that's going to fall between these two limits here. So both sides are going to add up to 5%, and 5% is the same as 0.05. Now if both these sides add up to 5%, well, one side is going to be 0.05 divided by 2. So 0.05 divided by 2 gives us 0.025. So our t-stat, we're going to be looking up the column 0.025. So if we look on page 41, our degrees of freedom is 19, and then we're going to be going over 3 columns, because that's the column 3 is the column that's associated with 0.025. And we go down there then, we go 19, go down to 19 and go across, and we get 2.093. So our t number is going to be 2.093. And that's where 2.093 comes from. So setting this up then, the formula, I'll just make a bit of space there. The layers are going a bit funny on me here. Let's see now, I'm going to have, so this is going to be the same here. Could have calculated this out separately, 5.98 over root 20. So just bang both sides of this into the calculator, and from one I did earlier, you should get, on this side you're going to get 380.65. so mu is going to be greater than that and less than 386.25. so we can say that we're 95% confident that mu lies between these two figures based on the sample data there. And hopefully that's right, and if you have any comments, or let me know if you find any problems or issues.